Okay, thank you, Sadia. My name is Jean Muntz, a member of Wild Ones, as she said, with our Start in Your Yard initiative. Tonight's presentation, What is Soil? What Do I Need to Know? By Mark Bramstedt, is the second presentation in this year's series called Under Our Feet. This series is made possible by the partnership of the Wild Ones of Greater Kane County, Start in Your Yard initiative, and the Gale Borden Library and the Elgin Sustainability Commission. We'd like to highlight our next events. First is this coming Thursday, February 23rd at 7 p.m. It is a panel discussion entitled, What About Invasives? You can attend in person at the Gale Borden Library, or you can register for an online attendance via Zoom at either startinyouryard.com or greaterkanecountywildones.org, greaterkanecounty.wildones.org. On May 13th, we will be holding our annual native plant sale at Gray Willows Farm. More information will be available in the future at the websites mentioned and the Wild Ones of Greater Kane County's Facebook page. If you're new to native gardening, you can request a certificate of attendance for this presentation. You need to go to the chat and you will see that Sadia of the Gale Borden Library, Sadia's email is listed, and you request at that site your certificate, or you can answer the reminder email you got today with the resource page in it. This certificate will be redeemable at the plant sale. And finally, whether you're looking for inspiration, information, instruction, insight, or intentional planting ideas, please visit the startinyouryard.com website. The website has all our previous presentations, and they are available for viewing along with information and direction related to native plants and natural landscape. And now I'd like to introduce Mary Alice Masonic, who will introduce tonight's speaker.
Thank you, Jean. Good evening, everyone. I'm Mary Alice Masonic. I'm a member of the Greater Kane County Wild Ones, and it is my pleasure to introduce Mark Bramstedt. He is a soil scientist, soil classifier with over 45 years of field experience in the classification and interpretation of soil and soil properties. He currently assists the Kane DuPage Soil and Water Conservation District with all things soil, and is also self-employed as a consultant at M&M Soils LLC. Most of Mark's career as a soil scientist was spent with the U.S. Department of Agriculture in soil mapping, soil conservation, wetland identification, and other issues of natural resource management, working with private landowners, universities, and local, state, and federal government agencies to understand how soil responds for various uses across the landscape. He is still amazed at the complexity of soil and the biodiversity and life within soil. With each examination of the soil, he learns something new. Here is Mark Bramstedt.
Thank you, and good evening. Can you imagine somebody spending 45 years looking at dirt? That's kind of a crazy thing for a career, but it's been fantastic. And so I'm here tonight to just talk to you about some of the things I've learned and see what you know about the soils in your area. Not only the properties of soils, but maybe some things that can help you in looking at the soils in your yard to help manage those soils for better use for the things you want to do with it. So we'll get started talking right away about what is soil. And when I went to school, this was the definition that was used. Dynamic means it's changing all the time. It's not static. It's something that changes. It's at the surface of the earth. So it's not deep bedrock, not those sorts of things. But it's near the surface. It's like the skin of the earth. Plants grow on it. It's made of minerals, organic material, and living forms. That's a pretty comprehensive way to look at soil. But I also think of soil more as an ecosystem. So it's got roots, it has living creatures in it, it's made up of a substance, but that's always changing. Again, dynamic properties. And it's really something that we don't think about on a daily basis, or even when you're out in the yard planting your plants, you're thinking about your plants and that sort of thing. But rarely do people actually think about the soil properties and how the soil can be used to benefit what they're doing. And you think about our houses, our streets, where we grow things, all those are connected to the soil. How we dispose of our sewage, that's connected to the soil, especially if you're out away from the city and you're on a septic field. So the soil does a lot of amazing things. So we're going to be looking at what actually is soil and what can we learn from that. So in the United States, we have lots of different kinds of soils, more than 20,000 different soil varieties. And the Smithsonian in Washington, D.C., along with the Soil Science Society of America, had an exhibit a few years back about soils. And these are the state soils. Each soil had a state soil that was represented in the exhibit. And you can see just here the variety of soils that we see in each of the states around the U.S. Here's Illinois, the Illinois soils on the left. I was fortunate to help in preparing this sample that went to the Smithsonian. So it was a wonderful exhibit to bring to the public just the information about what is soil. But what makes soil so different? Why is that one in the middle, those two in the middle, so red? And why is Illinois almost black on its soil? And the one on the far right for Vermont, it ends with rock at the end. And you can see just the different properties right here in this picture about how soil varies considerably from place to place. So let's take a look at what makes up soil. And in the first part of this presentation, I'm going to be talking about the 45% there that's called mineral matter. So you think of soil as something that's just solid rock almost. It's hard sometimes. You have to dig it with a shovel. It's difficult to get through sometime, but you really look at this, soil is actually about 50% pore space and 50% solid matter. We're going to be taking a look at this 45% of that solid matter, which is actually basically ground up rock in various sizes. We're going to be looking at that mineral matter and see the importance of that and what we can learn from that. We'll talk about the 5% organic matter and the 50% pore space later on in the presentation. But starting out, we're going to be looking at some of the physical properties of soil. And here we're going to be looking at mainly 4 of these properties. We're going to talk about what horizons are in the soil. We're going to talk about the significance of the color that's in the soil, the texture that's in the soil, something we can actually feel with our hands, and structure. There's actually building blocks that make up the soil. So we're going to be looking at those features and discussing how those are significant in how the soil functions. Starting out with the soil horizons, these are layers in the soil. Soil actually forms in layers. And I love chocolate cake. So when my wife makes a cake for my birthday, I always say, I want a chocolate layer cake. And because I love those layers, I think of that in soil, especially in our soils in Illinois. You have a lot of dark minerals. You can see the material actually flowing down through the pores in the soil. And it actually looks like that icing dripping down through the cracks in the soil. But in general, we have a lettering system that just simplifies how we talk about soil. Most of our soils do not contain an O horizon. O horizons are typically only found in really wet environments where you have soils formed from organic material. And most of the O horizons in our soils have been long gone, either by disturbance from humans or the importation of the European night-crawling earthworms. They have voraciously consumed a lot of the O horizon in our forest lands. So those are pretty well absent in most of our soils, so most of our soils start out with the A layer at the surface, the A horizon. Some soils contain an E horizon, B, C, R, L. not all these horizon letters are present in all soils, but it's just a general representation of it. And when we look at just a couple examples here from Illinois, we have the A horizon that's at the top. And if it's been plowed like these two have, we've added a subscript to that. So AP, the P means plowed or disturbed. And sometimes we just refer to this generically as the topsoil. So that makes sense. It's at the top of the ground. So that's the topsoil. So the A horizons constitute the topsoil. The example on the left has a real whitish layer below that. That's called the E horizon. It's E for the word eluviated, which means things have been removed from it. And it usually occurs under areas that have been impacted by woodland vegetation. So some savannas and then woodlands or forest lands would generally have an E horizon in it. Excuse me. And then as we transition from the E horizon to the B horizon is often referred to as the subsoil. The B horizon, then there's a transition layer there between the B and the layer between the E and the B below. And then the B horizon also shows some other subscripts. The T means that clay has been translocated or moved into that area. And that's typical for the subsoil, that layer below the topsoil. The subsoil usually has the highest amount of clay content in the soil. The topsoil generally has the highest amount of organic matter or carbonates in the soil. And generally the highest amount of biological activity occurs in the topsoil. So we call these two major layers, the topsoil, the subsoil, and we can divide them up into different categories. And again, these are just two examples of the soils in our state and how these horizons form. Now, soil color was one of the other properties that we were going to talk about. Soil color is very significant in many ways. One of the ways that I have described here is in estimating how much soil organic matter is in there. You know, organic matter is a key. We're going to be talking about that more later. It's key in plant growth and biological activity. So I don't know if you've ever gone to a paint store and you go in, you're going to get white paint and you realize how many whites there are. It's very difficult to choose which white paint am I going to get. Am I getting snow white or frost white or whatever kind of white, lace white, whatever it is, it's difficult to choose. Well, when we look at this page right here, to me, a lot of this looks like brown or yellowish brown. Well, how do you describe a soil to someone else to say it's yellowish brown when yellowish brown can mean so many other colors? And so back in the 40s, the US Department of Agriculture adopted a standard system for describing soil color by a guy named Munsell, Henry Munsell, and they put together this booklet, and this is used to describe soil color across the US and across the world. And each page of the book is a spectrum of the rainbow. This page, if you look in the upper right corner, is yellow-red. So this is number 10, yellow-red. And then if you look, the columns going up and down, you go from dark at the bottom to light at the top, they're numbered. And you go from gray on the left to intensity of color on the right. And that's the chroma of the soil. So we have hue, which is the page number, value, which is the darkness, and chroma, which is the grayness or strength of color. So we can say, like that area I have outlined in purple, instead of saying that's yellowish brown, we say that is 10YR 5-4. And every soil scientist across the world will know what color that is. Now you can see I've marked some of these to estimate when we're comparing the soil sample to these color chips, we can estimate the amount of organic matter that's in the soil by this comparison. We can also estimate things like, did the soil develop under wet conditions? Because those soils will have specific colors that go with soils that developed under wet conditions. And we'll see more of that as we go along. So soil color is a physical property of soil that really can give us an understanding of how the soil formed and how the soil is going to function for what we want it to do. Soil texture is another physical attribute of the soil, and this you can actually feel in the field. It's the proportion of the particle sizes that are present. We have the particle sizes really broken up into three categories. Sand, which sand particles you can actually see and are visible with your naked eye. They're the scratchy part of the soil, like sandpaper. You know, that's obvious on that. And you can actually see the individual sand grains in the soil. Silt particles are smaller than that, and you cannot see a silt particle with your naked eye. You have to use an electron microscope. They're that small that you need that kind of magnification to actually visualize a particle of silt. And clay is even more tiny than that. Clay is actually a molecular particle. It's built on the molecules of silicon and oxygen and other elements that come together, and they make these clay particles, these clay minerals. You need to have X-ray diffraction to be able to determine what clay minerals are present in your soil. So very, very tiny for the clay up to the larger sand particles that you can see with your eye, but you can feel the difference in the soils. And we actually have a way to do that using a little flow chart where you start with a sample of soil. You can see about the size of the sample that's represented in the gentleman's hand there. To squeeze between your thumb and your finger to determine how gritty it is, how scratchy does it feel, how smooth it is. The smoothness would indicate a higher silt content, and or how sticky it is, and that would be an indicator of how much clay is in the soil. Sand, silt, and clay, or the soil texture, really has a big function when it comes to water movement in the soil. And we'll see more about that in a bit. So you can use this flow chart and get an estimate about what the soil texture class is. Now, if you look at the triangle down in the lower right corner, that's the soil texture class. Again, these were put together by the U.S. Department of Agriculture way early in the 20th century. And these categories then are used to group soils together with properties that are texture classes that react similar to a lot of their water holding capacity, their ability to function for structural support, and those sorts of things. For example, in the lower, not the far right corner, but the lower corner on the right, we have silt loam. Silt loam is the most common surface texture we have in Illinois. And in our area in particular, we have about 5 to 8% sand in the soil, in the surface, and probably 25% clay would be pretty typical. 25% clay would be pretty typical. The rest of that being silt. So it falls in that silt loam category. When you look at the center of the triangle, that would be 1/3 of each particle size. We have clay loam. We often describe a loam soil. You know, people talk about having something that's loamy. That's just a little less clay than the clay loam. So you can see those categories where they are. The higher the sand, the more you move to the left of the triangle. The higher the clay, the more you move to the upper part, and the higher the silt, you move to the right. So those are ways to determine what the texture is of the soil. Then we have this thing called soil structure. And this is a more abstract, but you can see the pictures here. There's 4 main categories that we have. The surface layer generally, because of all the biological activity, has created this granular structure. It's kind of like coffee grounds or cottage cheese, just little granules of soil that are bound together by the substances that are released by the plants and critters that are in the soil. And it binds the soil together and makes the soil very stable, but it allows water to flow through easily and allows the roots to penetrate easily. So it's really a great structure for the topsoil, again, where most of this biological activity is occurring. Then in those areas that I said were influenced by woodland vegetation, forest lands, woodlands, savannas, you get sometimes this E-horizon, this layer that is lighter colored than the topsoil that's above it. And it actually forms in little flat plates. And you can see that lamination, that flatness in that slide there. And they'll actually be stacked on top of each other and are horizontally thin, flat plates. Sometimes they're thicker and sometimes they're very thin. And these look like to be pretty thin in this picture right here. So that occurs in that subsurface layer below the topsoil in those areas that were impacted by woodland. Then on the lower left, you have the blocky structure. That's typical of our subsoils, especially the upper part of the subsoil. where you have the clay moving downward from the upper part of the soil by water moving through the soil. It moves that clay downward and it redeposits it in the subsoil, and it builds these little blocks, these little building blocks that are there. As you get deeper into the subsoil, the structure gets larger, and you get these prisms, these longer soil features that are forming. You can see me holding some of those long prisms there, and they're coated with clay. The interiors of those structural units are a little more denser, but they have the cracks between the structural units, and that's where the roots and the waters go down. Roots and the water flows down, and you actually get the coating of the clay on the surface of those prismatic units. So these are building blocks in soils. Well, how did soil form? How did it get here? What is it about? Why is it different state to state? Well, we're going to talk about that, and we can think about it this way, is that there are 5 soil forming factors, and soil is a function of these 5 factors. It's a function of climate and organisms affected by the relief or the shape of the land, acting on parent material. We all have parents, so in fact, and soil has parents, so it's these factors acting on the parent material over a period of time. And I've got a little mathematical formula down there. Soil is a function of climate, organisms, relief, parent material, and time. Some people just say clorped. It's kind of hard to pronounce. I don't usually say that, but there it is. And so we're going to look at each of these factors and how they influence the soils in our area. So the climate, temperature and moisture, are the 2 main players here. And we see on the left side where temperature has been a factor. And if we get into Wisconsin, northern Wisconsin, Minnesota, where their seasons are colder, their growing season is shorter, they have more time where the soil is frozen. They don't get the growing season that we get here for all those factors to act on the soil. They don't get as much time for water to move down into the soil. And so they don't get a lot of soil development, as much soil development as we get here in the area that's called mesic. And that's the temperate temperature region that we have in Illinois. So we get a decent growing season. We get water flowing through the soil throughout the year. Only in the winter does it freeze up, and not for a real long period of time. We have biological activity for 9 months-ish out of the year. So we get considerable soil development. But if you go to the tropics, or southern Illinois would be in the thermic category, way deep south in the thermic, where they can grow cotton, where the growing season is much longer, where it's hotter. And then the tropics into the hyperthermic, where the growing season never ends, and you have lots of rain and all that moving through. So I've talked about moisture. Moisture, again, impacts a lot of the things that are happening in the soil. And here in Illinois, we mostly have these 2 moisture regimes, these 2 places with moisture. So in an area that would be in the Utic moisture, Utic just means moist. This is the area, it's not dried out. That would be more in the desert area in the south and southwest mostly. And then we have the wetland soils, they're in the aquic moisture regime. So you can see, we talked about color earlier, how these 2 samples down here differ in color based upon the moisture content that they have in them during their formation. And wet soils exhibit the gray colors, and we'll talk about that a little bit more later. But soil is a function of the climate. Soil is a function of organisms, it's not mostly one or the other. It includes both plants and animals, and we're finding more. The introduction said I'm amazed about soils each time I study it. We're learning more and more about what the critters do in the soil, the microbial activity. And your next presenter next month is going to delve deeper into what the microbiology and the organic matter of the soil is. So don't miss that. But the critters do play an important role on decomposing the dead material that falls to the earth each year from the trees, and as the grasses die, decomposing it and make those nutrients available for the plants to use, turning the soil over, mixing it up. Lots of processes are happening with the critters that are in the soil. On the left here, we just have 2 examples. We have what a soil in a hardwood forest looks like in comparison to the soil from the tallgrass prairie. And we see the blackness of the prairie and we see the grayish brown of the hardwood forest. And that has to do with the amount of organic matter that is in the soil in these during its formation. And we think a forest has a lot of organic matter because there are all these trees that are there that drop the leaves. But it's a different kind of environment, a different ecosystem. The forests have an acidic environment. The leaves, when they fall each year, they stay at the surface of the ground. They're not incorporated down below. And the acidic nature leaches out, removes a lot of that organic matter as it decomposes. Where if we have a tall grass prairie, we have fibrous roots that go deep into the soil, the roots diagonally, in comparison with the forest where the roots live for decades. And they're woody and, they're slow to decompose. Well, in the prairie, they decompose readily each season. They're deep already in the soil, and it's more of a basic environment. Instead of acidic, it's more of an alkaline environment. And so the organic matter builds up quicker. And so just those two reasons alone are why you get the differences there in how soil looks with the function of organisms. And in Illinois, we're part of this prairie peninsula. So we have this grassland that came into here when most of the tall grass prairie is west of the Mississippi. Illinois was fortunate enough that prairie peninsula extended into the state to build up the soils in our area. So again, that same picture shows the thick, dark surface layer, the topsoil horizon of the prairie soils. The relief, soil is a function of relief. So that relief is the landform, the surface topography. And here is just an enhanced topographic image of the landforms in northern Illinois. And you can see sweeping from Kendall County into LaSalle and then back curling around under Grundy County, there's a ridge there, a half moon kind of ridge, a crescent ridge there. And we'll talk about what that ridge is later on. It's called a moraine, and we'll discuss that in a bit. But you can see up in Kane, McHenry, it's a little higher, a little more bumpy. And as you look to some areas like Grundy County, it's real flat there. Grundy County is a very wet county. It's flat. So the soils there are going to look much different than they do up in McHenry and Boone and Kane County along those higher ridge tops. And so when you think about that, you think about the position you are on the slope. And if you're at the shoulder or back slope of a landscape, that's the areas that are going to be where the rain falls. They're going to be eroding and removing material in those areas. You get to the foot slope where it starts to curve concave wise. That's where that movement of the water and deposition is going to occur there because it's starting to slow down. And then you get at the toe slope, that's where the wettest area is going to be of this landscape. And same back on the summit, on the far summit, the further away from the shoulder you are, the flatter it gets and the wetter it would get from that too. But when you're near the shoulder, the summit will be have good drainage and have different properties than further away from that. So where you're on the landscape makes a difference in the soil properties. When we look at the landscapes and how it affects the depths to the seasonal water table in northeastern Illinois, all those blue areas are areas where you have the natural water table in the springtime when the soil is at its wettest. That's where you get a water table within a foot of the surface. And you look at a county like Ford County, which is down on the far right that has that long panhandle. You can see a big blue area there. That was one of the last counties in the state to be platted out because it was so wet. And people from Chicago used to go down there for hunting, duck hunting expeditions. The same up and to the upper left, you can see a large blue area there. That's a former lake that was in Lee County. That was well into the 20th century before it was drained away to make it farmland. So the soils vary, and we have a lot of flat landscapes and wet soils in Illinois. And so our properties, our soils reflect those properties. And here's an example again, where you have a soil on the left that was high on the landscape, maybe at the summit or at the shoulder, maybe even the back slope. So it has little water saturation for not very long period of time. It's never saturated with water. So the colors are more that yellowish brown color. That means the iron that's in the soil is well oxidized. So it's got that rusty appearance to it, that yellow brown. The brown, two coloring agents, I forgot to mention in the earlier part, The two main coloring agents in the soil are organic matter, that makes the soils dark or black, dark brown, and then iron, presence or absence of iron. If iron is present, you'll get the brown, yellowish brown, orange colors. If iron is absent, you get the uncoated soil particles, and that's what you see on the right side of the screen here. These are soils that occur in wetlands. In wetlands, the iron is transformed from one form of iron that's very stable in the soil to another form that actually goes in the soil solution, and the iron then is removed from the soil and it leaves behind the uncoated soil particles, and that makes the soil gray. So you're seeing the sand grains and the quartz crystals are that grayish color. The uncoated iron has been removed. So looking at the soil, when I took these pictures, originally there was no water in either soil pit, but the one on the right, I know that soil developed under wet conditions because it's basically gray all the way. So a very wet soil, just happened to be in probably July or August that I took the picture, so the water table is gone. But if I was choosing to build a house and I had this kind of a soil, I'd have to be aware of the wetness factor and then design my house around that, sump pumps and foundation drains and that sort of thing. And here's an example of 3 of the soils that occur in Kane DuPage area. Drummer soils are a wet soil that occur in the low part of the landscape. That's our state soil, by the way, and that's the soil that was at the Smithsonian, was a representation of the drummer soil. Elgin soils, they're a little less wet, and the Plano soils are considered well drained. They're up on the higher parts of the landscape. And so it looks like this. These 3 soils, the only difference between how these soils formed was their position on the landscape. They formed from the same kind of materials, the same climate, the same major climate, but the microclimates were different because the drummer soils are low. So being low on the landscape means that they're receiving more water than the soils higher on the slope. So adjusting the difference of landscape position, you get differences in how soils look. Parent material. Again, I mentioned we all have parents of some sort, and my mom carried the bald gene from my grandfather, so I have no hair. My dad was 5'9". My great grandfather was 5'9", so I'm 5'9", and so I reflect the characteristics of my parents. So these are the kinds of parents that the soils in Illinois develop from. Glacial deposits. That next word is loess, L-O-E-S-S. It's a German word. I probably don't pronounce it correctly, but in Illinois, all the soil scientists call it loess. Alluvium, stuff from streams, things that formed in bedrock. You'll see that up around Boone County or Rockford as you're going up there. You'll see the bedrock near the surface. Organic matter, we have some soils that are in bogs or marshes that are really spongy organic soils, and wind-blown sands, and we have all those in Illinois. Well, in Illinois, it's all about the glaciers when you're talking about parent material. And this representation shows almost the whole state covered almost the whole state of Illinois covered by glaciers. So just the southern tip is all that's exposed. So that's not quite true, but that's easy this size map to describe that. So we call these deposits here, these glacial deposits, the two in particular that we're going to talk about are till. Till deposits were made in the ice or right below the ice. And so they're dense, they're compact, they're a mix of sand, silt, clay, big boulders, all together, smashed together, and massive, pretty massive material. Then we have, and then again, that was right in the ice or under the ice as the glaciers moved across the landscape. Then we have the outwash deposits, and as the name says, they washed out of the glaciers as the glaciers melted. So the glaciers were actually dirty ice, and as the ice melted, the meltwaters carried the debris out across the landscape and deposited on the landscape. And you can see there it's formed in layers, where the till is pretty massive, all kind of one unit. The outwash forms in layers, and it's stratified with different particle sizes. After the glaciers receded, then the land was covered by wind-blown silts called loess. And loess is, all these deposits are higher pH, and the loess is mostly made of silts, and silts have the highest ability to hold water. So it's part of the great things about Illinois is that The glaciers created a great environment for the growing things in Illinois. And if you look at the map of the Illinois there, everything that is colored was covered by glaciers. And the only areas that are white down the Shawnee Hills down in southern Illinois, Pike County over there between the Illinois and Mississippi River, and up in Joe Davies County, they call that the unglaciated region when you get up into Wisconsin there. And it's basically, it's very much a beautiful, different landform than the rest of the state. When you look at the pink areas, that was the areas covered by the Illinois Glacier. That was about 250,000 years ago. But the area that we live in was covered by the covered by the Wisconsin glacial period. And that was about, it left the state about 10,000 years ago. And as we zoom in on that area, we can see that the darker green areas are those ridges. And you can see that area that I was talking about on that relief map. That's the Marseilles Moraine. I actually live on that in Kendall County, that Marseilles Moraine. It's the highest point in the county. The orange areas are where you have some major outwash deposits. The light green areas, those were the areas as the glacier receded, it left behind a glacial plain. And then the purple areas are areas where lakes form behind those moraines, those ridges. And there was a big glacial lake in Grundy County, and the area that's purple there, Lake Waponsie, and that's the reason why that area is so wet. It's a flat lake bed that was drained after the waters burst through the moraine and went down the Illinois River valley. So here's a local view of some of the glacial deposits near Elgin. There's an old oxbow of the Fox River there where Jelky's Creek is. And you can see the terraces along the river where you have those deposits of sand and gravel, stratified sand and gravel in there. And we have a lot of gravel pits up in Kane County, DuPage County, because of these outwash deposits. And then that Manuka Moraine, that light gray area, that is down here, it extends down to the town of Manuka. And we have a road on there called Ridge Road. I don't know if you've ever driven down Ridge Road going to Route 80, but the road is on the ridge of the Manuka Moraine. And so that's actually a glacial feature that's in this region where I live. And one more local feature, this is down near Sugar Grove. And Bliss Road is the road that angles from the upper right down to the center of that. And those orange areas, near area I have outlined in red, those are areas of glacial features called cames and eskers, where there were holes in the ice that filled up with gravel. Johnson's Mound would be one of those, where the area filled up with gravel and sand deposits. And those have been mined over the decades to extract those resources. And so those are some cool features about the parent material in our area from which our soil is formed in the region. And then the fifth of those soil forming factors, so we had climate, organisms, relief, parent material, and now we have time. Of course, I don't look the same as I did in high school. I actually had long hair in high school, no wrinkles, but you know, we've all changed over time, and that's the same with soils. The longer these other properties have a chance to affect the soil, the more the soil will change. So the soil on the left is a soil that formed or is forming in a floodplain. So every flood incident, it leaves new material and time starts over. The soil on the right is one from the tropics where the growing season never ends, the rain is constant, and things are moving through it all the time, and it's very well developed and highly weathered. So those are those 5 soil forming factors that make up the soils everywhere. And looking at, maybe want to know what the soils are in your area. Well, fortunately, guys like me and women like me spent years walking across the land, actually classifying the soils based upon pushing a soil probe into the ground down to 5 feet. We analyzed the material and we drew a map out where these different soils occur based upon those 5 soil forming factors. So this is at Hickory Knolls Discovery Center, just south of St. Charles. And I clicked on there's a site called the Web Soil Survey, managed by the U.S. Department of Agriculture. And you can pull up the soil map of your area. You can click on the map and it can tell you a lot about the soils that are in your area. and those physical kind of properties that we've been talking about. So easy to find out what you've got in your area, and these maps are they're the most highly examined county-wide map with the most data points than any other county-wide map that I've ever run across. These are available all across the U.S. for any place in the United States. So a quick summary of the properties of the soils that we have around us. They're dark colored because of the prairies. They have this high silt content because of the wind-blown material, the loss that came in. We have a lot of high water tables because of the landscapes that we are. But because these are prairie soils, they're high in organic matter. The pH is just right. It's more on the neutral to that slightly acid side, which is perfect for growing crops and plants and native plants and everything. They're relatively young. So they're naturally fertile, they're high productivity, but they have some problems. They're easy to erode, they're easy to compact, they get crusty, and they can get wet and sticky. So we have to manage around those sorts of things. So moving into the next part then is, how do we look at soils to make them, to maximize their benefit to us? And so a lot of people talk about this as soil quality or soil health. And it's basically the fitness of the soil to do what you want it to do. Generally, people want to grow things. And so this is going to be kind of focusing on growing of those things. And in this, we're going to look at things that we can manage in the soil. So we know those 45% of the soil is mineral. We're going to look at the 50%, the 55% that's not mineral that we can manage better. We can't really change that 45%. It is what it is. It's going to be sand, silt, or clay, and there's not much we can do about that to change it. But we can change what happens to the other parts. So when we look at soil under a slice and under a microscope, these dark areas show that it's pore space. So an ideal soil has a lot of pore space, a lot of holes in it. And those are where the action is. The pores are where the action of the soil occurs. And we're going to look at these three properties here: the pore space, or the compaction of the soil, the soil organic matter, and the soil biology, and see how we can manage these things for our benefit. So I'm going to stop my screen share for a minute and do a little demo here. So I like to, example I like to use is soil is like a sponge. So here we have a sponge, whoops, and you can see there's a lot of holes in it. And they're not all the same size. Those holes are different sizes. There's large holes, there's small holes. And that's like the soil. We can hold it in our hands, we can squeeze it, we can walk on it. It's solid, but it's got a lot of holes. So I have a bowl of water. I'm gonna dip this sponge like it's gonna rain, fill up the soil with water. So before I put it in there, the soil is dry. Well, now it's rained and the soil is saturated. And gravity removes the water out of those large holes that are in the soil. I'm going to speed gravity up a little bit. And it's no longer dripping. So gravity no longer has the ability to pull the water out, but the sponge is still wet. It's still wet. See, what's holding on to that water? It's the smaller pores that are in the soil, the capillary action. Like when you dip a paper towel in the spill on your counter, the capillary action pulls the water up. And that's what's happening here, is the small pores have a stronger force than gravity, and they're holding on to that water. So that pore space, then what we do with that pore space impacts how our plants are going to grow, how well water is going to enter the soil. The more we smash the soil, the fewer pore spaces we have. The more we till up the soil, the less pore diversity we have. I have to be careful not to get my computer wet. All right, I'm going to go back to sharing here. So we look at these pore spaces in the soil, and this is where the action is. When it rains, the grains don't absorb the water. The pore space absorbs the water. When the roots go down through the soil, they're not going through a mineral grain. They're going between the grains and the pore space. When a worm makes a hole he's not burrowing into a soil mineral, he's burrowing around the soil minerals. So pore spaces are critical for biological activity and for water movement in the soil. And we have these macropores, that's the big ones you can see really well, like where an earthworm or root went through. And we have the micropores that are much smaller. So again, pores are important. If we compact the soil, we lose that pore space. And we get these compacted layers in the soil, and the pore space is impacted most by tillage or disturbance. So the more we dig up the soil, the more we lose that pore space. And the more we walk in the soil or roll in the soil with lawn rollers, never do that, because you're actually just crushing your soil and getting rid of that pore space. We get this in modern subdivisions. This is what our soil looks like. The lower layer, all the topsoil is removed when they developed the subdivision. They compacted the lower layer. They put the topsoil back on, compacted it. It's very cloddy, it's very dense, it's very hard. And the roots, when they can find a crack, go down, but there's no continuity between the topsoil and the subsoil. And the roots then just flat out at the interface between the two. And that affects then how much water goes in the soil, and flooding increases in areas where water can't get in the soil and it runs off quicker. And so these things are all impacted by what we do with that soil pore space. And I'm going to speed up a little bit because I know we're kind of running short on time, but a lot of people think that when they get water standing, this is a typical farmer thing, they get water standing in the field, they think they need better drainage for their soil, but they don't. They've actually destroyed the pore diversity by tilling the soil. All the pores are the same. So the soil basically seals over when it rains, and water just is not able to infiltrate. So I've got a 30-second video here that's going to demonstrate that a little bit. This is Ray Archuleta, who's from the U.S. Department of Agriculture. And
I want to show you how soil disturbance through tillage impacts soil function. Here are two soils. This soil has been disturbed by conventional tillage. This soil has not been tilled for 40 years. It's virtually undisturbed. Watch what happens when I simulate rainfall on these two soils. The undisturbed soil allows every precious inch to infiltrate. This is good for your production and for the environment. The disturbed soil does not allow the water to infiltrate. Most of the water is going to run off. Place your soil into drought mode and put your nutrients into the nearest lake. So when it comes to building healthy, productive soils, remember, do not disturb.
so what makes pore space? The soil texture helps separate those soil particles within the structure. It's the foundation. Organic matter is the key for letting water in and for building the biological activity, and the critters rule the underground. So again, back to this texture, it's the particle sizes. We have these categories that are here. And you see that in a sandy soil, the pore spaces are large. In a clayey soil, the soil spaces are small. So the sand lets water move through quicker, the soil much slower. There's actually more total space in the clay soil, but a good combination is desirable. Unfortunately, most of our soils have good combinations. Again, structure helps water flow differently. You can see the granular water has an easy path going through there. You get that platy structure, how the water takes a more tortuous path to get through. So structure is a great thing, and we want to maximize the amount of granular structure in the areas that we're planting or working in. Organic matter is a key to almost every biological activity in the soil. And I like to say soil organic matter is chicken soup for your soil. And that's because it affects almost every biological property that we have in the soil. Organic matter is basically anything that is alive or was alive that's in the soil. And it breaks down through the actions of microbes around the root channels. And they're able then to make those dead leaves, that dead grass, become a usable product then for the plants to grow. They are able to take a dead leaf and make it for nitrogen or potassium or whatever for the plants to use. In particular, I'm going to want to show what fungi does. It's one of the more exciting things we've learned about soil biology in recent years, and how the fungus can impact the stability of your soil. So the soil on the left here had a rich, undisturbed soil profile and the fungi were present. The fungi release a sort of glue to help bind the soil particles together, where the soil on the right is like the soil we saw in that last demo. It flows together and it seals off the soil surface, and it's not able to get through because it sealed the surface. So one more little quick video here about soil structure and how it impacts the stability of the soil. So we'll see here, Ray again.
I have a question to ask you. Is your soil healthy, functioning, and stable? One of the best visual diagnostic tools that I know of is the soil stability test. Here are two soils, exactly the same soil type. This soil has been tilled for 30 years. This soil has not been tilled for 40 years. It is covered with diverse plants year-round. Watch what happens when we drop the soil in the water. Notice how the conventional till soil is falling apart. The biotic glues in the organic matter are burned up by tillage. The soil pores have collapsed. Notice the no-till soil. The pore spaces are still intact. Do this test for yourself. I guarantee if you dig a little, you'll learn a lot.
All right, so summarize here about the physical properties of soils. They formed in loess, glacial drift. They're high in silts, which are great for holding the water for our plants to grow. Not too clayey, not too sticky, a lot of great organic matter, very fertile, but they've got some issues with erosion and compaction. And then when we're looking at managing the soils, we have to remember pores are where the action is. Organic matter is the hub to all these biological processes that you'll learn about next month. And the soil critters then that make that soil organic matter available for the plants. They rule the underground. So how do we get there? How do we make our soils better? We minimize disturbance. We keep the soil covered. We keep living roots in the soil as much as we can, and we maximize biodiversity. Lots of quotes about what people think soil is. And at this time, I'll take any questions. I know I'm cut it quite short for questions, but we still have a few minutes.
Can you hear me?
Yes.
Yes, okay. Yes, there have been a few questions come up. Oops. Find the questions. Yeah, all right. Well, a question was, will the slides be available to us? And I think this was recorded, so I believe that they will be available in that way. Another question was, one that puzzles me greatly is why home builders always scrape the topsoil off the site. Wouldn't it be better if the topsoil were just left in place? Or would the compaction negate the benefit of leaving it in place?
That's a good question. It's one I've pondered myself, but I think it's easier to develop a subdivision by just stripping it off, putting in the roads, and then putting it back. And I think it's just ease of that. And we've tried to work, when I was with USDA, we tried to work with counties to maybe incentivize developers to not do that. But I guess the advantages for development are greater the other way.
And another question from Terry is, does not disturbing the soil mean that we shouldn't turn over the soil in a vegetable garden?
Why do we turn over areas that aren't being planted would be my question. And I would say if you would only disturb the area where you're putting in the plant, there would be no need to, there's no need to turn over the rest of the garden because you're not doing anything there. And actually, there are some disadvantages for doing that besides what I've mentioned. And some of that is mixing in weed seeds and that sort of thing, but keeping the soil covered and keeping that. The thing is, when you don't disturb it, you get pore diversity, where you get a pore that forms at the surface that will go all the way down 2 feet into the soil. But once you turn it over, you break that, and you no longer now get water infiltration and airflow from the surface downward.
And a question from Rachel. What is the best thing I can do to understand my soil at my new Elgin home?
Well, I would first go to that web soil survey, and you can see what kind of materials the soil formed in. That would be one thing. The other thing is, I don't know how deep you want to know what the soil is like, but beyond that soil survey, just take a spade out into your yard and take a chunk out and take a look at it, smell it, feel it. Does it have a lot of holes in it? Is there a lot of earthworm or biological activity? How dark is it? If it's sticky or not sticky, wet a little bit, moist, and try it, feel it in your hands and your thumb and your finger and see how sticky it is. Those will all be things that help you understand what's there. You can also do a home soil test, but it's really pH is the only test that's going to be that usable for you. And again, from the materials from which these soil form, they're usually higher in pH. So most of our soils are going to be neutral or slightly alkaline here.
And here's a question from Darlene Castelvecchi. What is the best way to handle clay soil?
It's hard to change the texture of soil. And so you can't make it less clayey. But what you can do, and what I've done, because I'm in a modern home that when they dug the foundation, they just piled the clay around the outside of the house. I've used a lot of mulch, organic matter, compost. And again, organic matter is chicken soup for the soil. So it's clayey, you add organic matter. And that's the best solution. You can add it just by putting it on top. You don't have to mix it in. Over the years, it'll decompose and it'll work its way in there with the activity of the earthworms and other biota that's in the soil.
And a question from Elizabeth Copeland. How do you go about changing the minds of farmers to switch to no-till?
We've at USDA, when I was at USDA, it's been for years, that's been the issue. I think when the farmers owned the land, they were more likely to do no-till. A lot of decisions for farming is based upon economy. And so it's got to be economically feasible. But what's happened in recent years is more people have moved off the land, and the owners of the land now want to maximize their return, and they're not knowledgeable about the soil, and they're not as concerned about maintaining the soil quality itself, maintaining a legacy of the soil. They just want the quickest return. So adding fertilizer will benefit the return, and tillage is faster and easier than managing it with no-till. And I think that's what it is. Farmers don't have long-term leases on the ground anymore. Most of the ground they farm are just year-to-year rentals. And so they try to get the most out of the ground that they can.
And what is your opinion of landscape fabric or black plastic that prevents water from going through? Isn't this highly damaging or death to the microorganisms living under that fabric?
Whenever I've had any landscaping fabric in my gardens, when I moved to a new area, I've helped some other people, it's the first thing I take out because you're right, it prevents water from going into the soil. It prevents, it seals it off. The biological activity doesn't have access to it. You don't get the roots down. And eventually above the fabric, it's going to get weedy anyhow. So you might as well not put it in the first place.
Yeah. And a question, another question is, ours was one of the homes where the soil was removed when our home was built 35 years ago. We have been trying to improve the soil. Is there an optimal depth of topsoil?
Well, I think it depends on what you're growing. Bluegrass only requires a few inches. So if you have a bluegrass yard, you don't need much. And that's what most people have. If you're trying to grow native plants, you want the more you have, the better. And adding little skiffs of compost onto your soil year to year, adding mulches and all those sorts of things will help benefit that and increase that organic matter in that upper layer. But Without our help, it takes about 500 years to form an inch of topsoil. So it's not something that's really going to change much in our lifetime unless you're adding material to it to help build it up from the surface.
And here's a question from Shireen Gould Dulabaum. Is there a way for everyday people to check the amount of biodiversity of the soil organisms in their yard?
There are some fairly simple soil health tests, and one you can do where you it's not an expensive test, and you can make a test out of simple equipment. I don't have that to show you right now, but you can actually measure the respiration from your soil. You can do things to use a liquid to see how many earthworms are there. They'll come to the surface. You know, there's certain things you can do, and there's a whole information about soil health. If you go to the U.S. Department of Agriculture and search for soil health, you'll get a lot of examples for doing those kind of tests.
And here's a question. Is putting down cardboard harmful to the soil? I guess that would be for smothering weeds, maybe? I'm guessing.
I'm guessing that too. I don't know because it's cardboard. If there are things used in the manufacture of the cardboard that may be bad for the soil, I guess that could be, but most of the soil is cardboard, which is carbon. You know, it's organic material. It'll eventually decompose and be part of the organic matter. But again, there may be some glues or something that's used in the cardboard that I'm not familiar with.
Here's a question. Farmers are now using cover crops. Does this mean they don't till to plant in the spring?
Not necessarily. They can put on a cover crop in the fall. They can till that under in the spring. That's a new thing of soil health. You know, those 4 things I showed at the end: keep the soil covered, keep living roots in the soil. That's what they're trying to do. Some of the crops die naturally, like the giant radishes, they die naturally, but some of the other ones, some of the other cover crops, they need to kill before they plant. So it's not competition with their crop. So some they can do by rolling it, some they can do by chopping it, some they have to do by tilling it.
Jill has a question. Is there a good place to get a soil test? U of I Extension doesn't do it. I know of TPS labs, but they are pretty pricey.
Yeah, if you're trying to test for nutrients, like how much calcium or magnesium or whatever you have in the soil, they're going to cost you some to do. And again, our soils are pretty fertile. Even though they've been disturbed, the fertility is still there, and it's more about managing it. But there are some soil labs, but they're just going to be more expensive. The home soil kits, home soil test kits, you know, they're going to do okay, but they're going to give you a range. It's not going to be very precise. And even farmers, when they test for nitrogen or carbon or those sorts of things, none of those are extremely precise, and because there's so many factors that are involved, and there's different ways of testing. So it's a relative idea about how your soil is. So it's a relative idea, but not a precise idea of what kind of nutrients you have. It's a good way if you're actually trying to actually manage specifically for certain things, get a soil test from a soil lab. That's the best you can do. And they'll help you then with recommendations depending upon what you want to do with the soil.
Thank you. Another question is, how can we increase the pore space in the soils of our yards? Will doing so naturally attract microorganisms to the area? Right.
So add organic matter by compost or keeping living roots in the soil, maximize diversity. All those 4 points at the end, those are the things that will build pore space and build biological activity, and it'll come on its own. Once you get that organic matter in there and it's decomposing, you'll get the microbes will return, and you'll start seeing improvements after a few years.
Corey has the question, how long does it take to add an inch of topsoil to the land? I think you answered that.
Yes, yeah, about 500 years under natural development conditions. That's what I've been told.
Okay. How do we plant things if we shouldn't disturb the soil?
Well, if you're planting a plant, you know, you already have a growing plant that's in a pot or a plug, disturb the soil where the plant's going. So just dig the hole where the plant's going and put the plant in. If you're planting a row of beans, just disturb the area where the seed's going to go. So you get good seed soil contact, but you don't need to go in between the rows. There's no reason to disturb the area in between the rows, but you can disturb a little narrow strip down the center where your seed's going to go.
Another question from Shireen. How does the street sidewalk salt we put out impact our soil? Is this something I should be concerned about? Should I use an alternative?
It impacts the soil when it gets on the soil. So generally, if it's on the roads and streets, it's going to impact water quality more than it's going to impact the soil. If it's on your driveway and it rushes off into your driveway, yeah, it'll increase the sodium on your soil there. It may damage the plants that are there. Southern Illinois has soils that are high in sodium, and they have a lot of issues with those. It's naturally occurring, but they have a lot of issues with those. They hold water a lot longer. They don't drain well. They're harder to work with. So sodium can be a negative impact. Yes.
And Jill asks, do you know much about biochar? And what is your thought on it?
I don't know a whole lot about it. I haven't studied it. I haven't read any research about it, but it's organic matter. It's decomposed somewhat organic matter, but you can do the same thing without biochar. You can make your own compost pile and add fresher organic matter to the soil. So yeah, it's not bad. I think there are other methods.
Okay. Tanya asked, I asked how we are supposed to plant if we are not to disturb the soil. And you've said several times to avoid disturbing the soil as it destroys the pores. If we want to avoid disturbing the pores, what is the best thing to do in both large and small spaces?
Yeah, again, if you have a plant, you disturb the area where you're wanting to plant it, but you don't need to disturb the area beyond that. And the pore spaces will form between those areas. But once you destroy the pore space, it takes a while to rebuild those. And by giving it time, it will rebuild. I pull the mulch away from the area around the foundation of my house, and I've lived here for 10 years, and the pore space is fantastic. And this high clay, sticky soil, because I don't turn it over. When I plant a plant, I just dig the spot where the plant's going and leave the rest there. And it seems to work okay.
Dan asks, is mushroom compost beneficial?
I've heard that it's got a lot of good nutrients to really make things take off, but I think compost of any kind is beneficial. So yes, it's beneficial.
Sue Steyer mentions that Farm Bureaus offer soil testing, and she has a link that I can put in the chat, I think.
Yes. And there are several testing services around.
All right, I think that's the end of the questions.
Okay. I did have my email that I didn't show at the end. I was going to post up there, and I can send it to you, and you can post that later if you want.
Okay.
See if people have further questions. Or great thing to do is each county has a soil and water conservation district. Kane and DePage are together. Their offices in St. Charles on Dean Street. That would be the first place I would go. They're co-located with U.S. Department of Agriculture, Natural Resources Conservation Service. So they'd be the first go-to for questions about soil health, soil problems. So I would go there first, and there's lots of resources on the internet, so you can check some of those out too.
There is a couple more questions. One is, how does fire affect soil?
Well, it burns up the organic matter. That's one thing. So you no longer have that fresh organic matter to put in it. You have the ashes from the organic matter, still a little bit of carbon. It can seal the soil surface, especially I know out west when they have the forest fires, they get the resins from the trees, and it forms a coating on the surface. It seals the soil over, and that's why they get a lot of landslides after forest fires in California, is because the water can't get it into the ground as easily. And so you get a lot more runoff and landslides. So fire can impact the soil in those kinds of ways. Plus, it'll kill any biological activity that's close enough to the heat.
Mushroom mulch used to be everywhere. Is there a reason why it has disappeared?
That I don't know. Supply
Okay.
chain issues, I guess.
Okay. And Beth asks, she says that I had the water pipes in my front yard worked on, and the workers drained water and soil into my backyard, and it all went into my garden by accident. How can I fix it?
I'm not sure what she wants to fix.
So there's some soil and water went into her garden by accident.
Oh, so you want to get the sediment out. I think it'll take care of itself unless it's really a thick pile. You could just rake it around and spread it around.
And one question is from Dom, is it good to aerate the lawn?
That's a good question. You know, I was just out in my yard today and it had been warmer a few days ago, and now it was refrozen this morning, and I noticed the soil was all bumpy. The land was all bumpy again. Well, that's just nature refreshing the soil and creating pore space, because it's freeze and thaw causes the soil to expand and contract, and that's creating the pore space. I've aerated my lawn once or twice. I'm not sure it's that great, because I think nature can take care of it itself. If you have a real compacted area that maybe a path you walk on mostly and you want to aerate that, I think that would be fine, but I don't think it's necessary for a whole lawn. That's my opinion. I don't have the study to support that.
All right. Well, thank you very much, Mark, for presenting on this. And thanks to everyone for attending. Please watch your email for a certificate of participation, as well as a handout of resources. And as was mentioned earlier, our next presentation in our series on soil will be on March 7th at 7 p.m. The title is Drama Beneath Our Feet, Soil Organisms and Organic Matter. And it will be presented by Emma Lovins from the Morton Arboretum. Thank you, everyone.